For homework, I created a model v4.homework in which I define this type pay params, which has two fields, a pub key hash and an integer. Then I define a schema that has one endpoint called pay with those parameters. And I define a contract that has trivial state, observable state, uses that schema, text error messages. And how does it work? Well, I use endpoint to wait for somebody from the outside invoke that endpoint. So this will block until the endpoint is invoked. Then PP will be bound to the pay params. Then I specify transaction by giving the must pay to pub key constraint. As the name suggests, that adds the constraint that this transaction should pay to a pub key. So the pub key is the first argument. I extract that from the first field of the provided endpoint parameters. And then the value is the second argument. And so I extract this integer from the second field of the parameters and use a function called loveless value of that will turn that integer into a value given in loveless. In line 31, I construct and submit the transaction. So what that will do is it will look at these constraints and then try to construct a transaction that satisfies those constraints. So in particular, it must find an input in the wallet that is large enough to cover this payment and the fees. And it might also need to construct a change output going back to the wallet. And once the transaction is constructed, it will submit it to the blockchain. And then I recursively call the contract again, which means that you can call this endpoint over and over. So what I would like you to do first is implement this pay trace. So the idea of that is it takes two integer arguments and then returns an emulator trace. And the behavior should be that in this trace, you first start the contract in wallet 1 and then do two endpoint calls to the pay endpoint, where the recipient in both cases is wallet 2 and the amounts to be paid are given by these two parameters. So first parameter, first endpoint call, second parameter, second endpoint call. And after each of the endpoint calls, please wait for one slot. So that's the first task you should do. And then I provide these two tests where I try this trace with different values for the arguments. 1 ADA and 2 ADA in the first case, 1000 ADA and 2 ADA in the second case. If we try the first one, we see it works. So here we have the two endpoint calls. And if we look at the final balances, we see that wallet 2 indeed has 3 ADA more. 1 from the first payment, 2 from the second payment. If, however, we tried paytest 2, there would be an exception in line 31 because wallet 1 only has 100 ADA. I'm using the default configuration and we learned that that means 100 ADA. Each wallet has 100 ADA. So it doesn't have 1000 ADA, so it can't construct a transaction that can pay 1000 ADA. So once it reaches this line 31 for the first time, there will be an exception and this contract will stop. So in particular, the second endpoint call from the trace will never do anything because the contract has already crashed at that point. So the second thing I would like you to do is modify the pay contract so that this exception gets handled. So instead of crashing, it should be caught and then just logged. So just produce a log message that shows the exception. And once you have done that, when you invoke paytest 2, this should happen or something like that. So upon the first endpoint call, it doesn't crash. We just get a log message called error and then the error. So in this case, it will be an insufficient funds error. And the second endpoint call will then still proceed. And in the result, we see that wallet 2 has 2 ADA more. So the first one with the 1000 ADA failed, but the contract kept running. The second endpoint call successfully transfers 2 ADA to wallet 2.